Hey, all you cool cats and kittens. We're going to be working on the area of a regular polygon today. Um, Area of a regular polygon we've done before, but this is going to be using something called an apothum. So, first things first, let's talk about what is an apothum. An apothum is a line that goes from the center of a shape to bisect the side. You remember regular polygons, for starters, regular polygons all have the same length sides and all have congruent angles throughout. Okay, so that is a regular polygon. An apothum goes uh, from the center of the shape and bisects as a perpendicular bisector to a side. Okay, that is an apothum. It's a line that goes from the center of a shape and is a perpendicular bisector to one side. It's like a radius, but it's not. It just goes to the side. It does not go to a corner. It does not bisect the angles, nothing. It just is a perpendicular. It's like the height if you were looking at this as a separate shape. Okay? It's a perpendicular bisector to one side. All right. So it goes from the center, that's key, and it's perpendicular bisector, that's key. Now, with all regular polygons, we can find out this central angle, right? Regular polygon, for this one, it is a pentagon, so it has 5 central angles. And central angles bisect each vertex. Okay? All right. So how do we find the measure of these central angles? It is just 360 divided by the number of sides. In this scenario, it would be 360 divided by 5, which is 72 degrees. So each one of these would be 72 degrees. Okay? All right. So to find the area of these shapes, we're going to use that word apothum that we just learned. Area of any regular rectangle or regular polygon, sorry. Any area of any regular polygon is going to be 1/2 times the apothum times the perimeter of the shape. So the apothum is that A, and the big P is perimeter of polygon. So 1/2 times this piece times all the perimeter. All right, let's do it. Let's look at number one's pretty basic. It's very straightforward. It's a 5-sided figure. It gives you a side and it gives you the apothum. Plug them in, find the answer. Number two is a little bit different. Number two is a square. You can't have a regular rectangle. There's no such thing. And it gives you this piece right here. It gives you that piece right there, and it says that piece is 7 centimeters. Okay? Well, that's not the piece we want. We want the apothum. The apothum goes here and is a perpendicular bisector to that side. Well, we know if this is a square, these are 90 degrees. Whenever we have a central angle here, it cuts that in half, which means we now have a 45, 45, 90 triangle. We know that our ratio for that is x, and this is going to be x times the root of 2. So if I know that this is equal to x root 2, I can divide both sides by root 2 to find out what x is. So I know that x, this apothum length right here, is going, or we can call that a on the side here, x is going to be equal to 7 over root 2. Well, because this apothum splits this and these are the same for the square, I know that the perimeter around this shape is going to be, well, each side is 2 of these x's. You remember they're perpendicular bisectors. So if this is x and this is x, so each side is 2x. Okay? If I multiply it all the way around, that's 2 times 2, that's 8x. So I know that my perimeter is going to be 8 times 7 over root 2. Okay, so I can plug all these values in. This is also my Opossum. I can plug all these values in, multiply it times 1/2, and bing, bang, bam, done. All right. Oh man, my nose is super itchy. All right, so let's do that. We are going to get area is equal to 1/2 times 7 over the root of 2 times 56, 8 times 7, 56 over the root of 2. We're going to multiply that all together, and it's going to end up with 98 centimeters squared. Okay, let's skip ahead to number 3 is pretty basic. You're going to have a 30, 60, 90 triangle, so you use those measures. What is it? X root 3, and 2x. Just as a reminder for number 3, 30, 60, 90 triangles. This is 30. This is 60. It's going to be x, 2x, and x root 3, just as a reminder. So you find that very much the same way. Number 4 has a hexagon. And it says that it has the Opossum as 5 root 3. This is our Opossum. All right, so we need to find out what this piece is, so we can multiply it times 2 times 6, or multiply this times 12 to get the whole thing. All right, well, we need to know a couple of things. First, we're going to draw a triangle. We know that this is 90 degrees. We want to know what that is. We know what this is, and we know what this is. How do we know? Well, we know that this central angle is 360 divided by number of sides, which is 6. And that is, 60? But we know this is half of that, which is 30. So I know that this is 30 degrees. Okay? Just this one right here. So we're going to use SOHCAHTOA here. We have the adjacent. We want the opposite. Which one uses adjacent and opposite? That's TOA. So we're going to have tangent of 30 is equal to opposite over adjacent. We're going to multiply both sides by 5 root 3. And that's equal to x. So, you remember, this side is actually 2x. X is here, and x is here, so the whole thing is 2x. But we want to know what the perimeter is, so that's 1, 2, 3, 4, 5, 6. So 6 of 2x's, which is really 12 times x, and this is x. So let's plug it all in. My area is equal to 1/2 times my Opossum, which is 5 root 3, times 12. This is all 12 times 5 root 3 tangent 30. That's an N, I promise. Tangent 30. Okay? You can simplify that if you'd like. That's 60 root 3 tangent 30. You can do all that stuff. All right. So 0.5 times 5 root 3 times 60 root 3, or 12 times 5 root 3 times tangent of 30. Oh. Times tangent of 30. All right. We hit enter, and we get 259.8. So that whole thing is 259.8 centimeters squared. All right. Let's skip ahead to let's do number 5 is basically the same thing, except we're going to do 22 and a half instead of 30 because the central angle is split up into 8. So let's do number 6. Number 6. Number 6 says it's another pentagon. And it says that this piece is 10 inches. And then it says this whole thing, let's see. Right. It says this is 10 inches, and we need to find the Opossum. And we know what the central angle is going to be. We know this whole central angle is 360 divided by 5, which is 72. So this portion of it is going to be 36. So that's 36 degrees. And that's going to help us find our Opossum. And then it's going to help us find this piece, which times 2 to get that side, times 5, or times 2 times 5 is 10 to find the perimeter all the way around. So we have area is equal to the Opossum, which is what? We have hypotenuse and we want adjacent. So that is what? Toa. Yeah. We have cosine of 36 is equal to adjacent over hypotenuse. Multiply both sides by 10, and that helps you find your Opossum. So 10 times the cosine of 36 is equal to 8.09. All right. That's a little a, sorry. So our area is equal to 1/2 times 8.09. Now we're going to use that same sort of thing to find this piece right here. Let's call it x. So we have 36 degrees. We have 10 inches. We're going to be doing opposite and hypotenuse, which is sine. So sine of 36 is equal to opposite x over hypotenuse 10. So 10 times sine of 36 gives us x. And that is 5.87. But you remember, that's just this piece right here. We need to multiply it 2 times 2 to find the whole thing. And then we're going to multiply it by the number of sides, which is 1, 2, 3, 4, and 5. And that is our perimeter, 58.77 or 78. So 58.78 times 0.5 times 8.09, and we get 237 and change. So we knew that the area is equal to 237.7, let's call it 6 inches squared. All right. I hope that helps. If you have any questions, please let me know. You have a great, wonderful day.